Hello, everyone. Welcome back. For today, continuing with patterns, we have reviewed Observer and then Singleton. I just want to quickly check the source code for Singleton, and then we can review another one, Decorator. So far, previously, we talked about 3 categories of patterns. We review one here from behavior. We review one here for creation of objects, the simple one, the Singleton one. Something that I would like to do is to close the loop and review one for structural decorator. So with that, we could have an idea of each of the categories, knowing at least one pattern in each of these categories and when those patterns should be used. What we can do then is review at least another one and then put everything together to do the design of a particular assignment and see what happened. Well, the topics for the week, you can check on Canvas. I create one module per week, and each module usually have the slides and the lecture. So you can check there the 2 lectures that correspond to the week 4. Yeah.
Yes, thank you. Thank you.
Okay. So moving forward. For the Singleton, I have the opportunity to review with you the class diagram. Very simple one. Something that I want you to be aware is there are 2 versions. There are 2 possibilities. Number one, this one, in which you put the attribute in the attribute section of the diagram. But also, as we described with the class diagrams, you can have the possibility of doing the diagram with the method, the private constructor. That is important. You cannot avoid having that. The public method for getting back the instance. Those should be there. But the variable, as we described before, if you put the variable, this is the diagram, but you also can have not the variable, but a relationship between the class and the same class. A relationship that obviously is an attribute and therefore imply the use of a diamond. Because it's one or nothing, because the attribute can be null, the diamond is not black. So when you have this class and you have this loop in the class, one possibility, the only opportunity for that to be something good, quotation marks, is maybe it's a singleton. But you need to check for the loop, and you need to check for the private constructor, and obviously for at least one method, public, that give you access to the variable that you have encapsulated inside of the class. So just for you to be aware, option A, option B, the original one, the one described in the book, option A, probably the most common, but if you're wondering, can I replace this one with the relationship? The answer is yes, you can. It is possible. Good. So the source code, pretty simple, kind of very, very direct. You know the diagram, you know the meaning of each of the elements. I am sure that you can agree that the red elements are key in the source code for a class that is a singleton. Number one, you need to be aware of the name. This is a template. The name of the class could be professor, student, data, connection, sensor, database, whatever. The name of the class, it is not mandatory to be singleton. Singleton is a template name. You replace that name with whatever is in your problem, the class that you want to be a singleton. Singleton is a role, not the mandatory name for the class. So the only reason, because I put here this in red, is you need to be aware that whatever is the name here, whatever is the name of the class, well, is going to be exactly the same. That is going to be the type for a variable for the instance, and also is going to be the same. That is the name of the constructor that should be private. Or if you're planning to do inheritance, hopefully you agree with the idea, protected. For the scenario of the singleton, private, only the class can use it, or protected, only the class or the family can use it, is the same. What we are doing is avoid the constructor to be public, as is the standard. And a method that usually you're going to found this method being a getter and therefore having get something, and commonly get instance just because you are getting this variable instance. But the key idea is you identify the method not because of the name, but because of the data type. So you have the class, the instance, the constructor, and the method 4 times the same name, whatever is the name of the class. And this is kind of the signature for your singleton. Moreover, always the source code for this getter is going to include an if else. And the only thing that the condition is checking is whether or not the instance is null. And if the instance is null, create the instance. If not, return. That is the method that is doing the work of being sure that there is only one instance always, and that you have access to the instance. Pretty simple. Is one of the few patterns that do not use inheritance or realization, and that are used one class. 3 elements here. When you want to use your class, again, whatever is the name, the only thing that you can do with your class is to call the method that is public, in this case, the get instance. And that method gives you access to the instance. If you notice here, these two, name of the class, name of the objects, and usually there you will put equal new singleton or equal new whatever is the name of the class. What we do with the singleton is you're going to be equal to the name of the class dot the name of the method. They are static, remember? And if you compare these two, and I am using the equal, because what I want to compare is the address, the reference, and they are going to be true. They are going to be equal, because even though I try to do 2 objects, S1, S2, I am calling the singleton, and those 2 are just basically pointers to the same guy, the only object that exists from this particular class. And I can create several different references, pointers, and all of them represent exactly the same guy, controlled by the singleton class. Yes, a singleton can have a family, a singleton can be a parent. Yes, you can have that. And you can think about the power of that, in which the constructor here is private, the constructor in the child could be private, protected, whatever. And you have a family of singletons. A family in which you can even use polymorphic behavior. And it doesn't matter if you have one object parent or one object from any of the childs. It's going to be one and only one from a particular family. An important thing, guys, you can put together patterns. We're going to review this later, but you can have one class in which you can put there as many patterns as you want. Think about this in a classroom. In a classroom, we want one and only one professor, and we want several students there. You can make professor a singleton, one and only one. And moreover, you can make professor an observable. Is a singleton, only exists one, is observable, and the students in the classroom are observing that one that is a singleton. you do not need to have professor as a singleton, just to give you the idea of the combinations that you can do. You can combine as many patterns in the same class as you need. And moreover, always, 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 you can continue using composition, aggregation, association, and so on. It's up to you for the problem that you are solving. Anyway, we're going to work in putting together different things in a project later. For now, my goal is that you understand the patterns individually, the key elements of each of the patterns. So key elements for the singleton. When you saw something like this, you are using a singleton. When you saw something like this, those 4 elements in one class, whatever is the name, that class is a singleton. You could be thinking, the observer? You use the observer every single time that you create a listener in Java. You use the observer before you even know that there is a pattern observer, because you learn to use listeners. And that is part of your maybe 110 programming class, doing graphical applications with listeners. What about the singleton? Did you recognize singleton in any library that you have used before? Answering the question, the singleton, the constructor, should be private or protected. It's the same. The rule is should not be public. In the template, private, we put the minus. In my example, something that I am mentioning to you is you can put protected if you are planning to do inheritance. Remember the meaning of protected, private for the family instead of private for the class. So private or protected, not public. That is the rule. So I am asking you for examples, and yeah, 2 examples that I am sharing with you. If you have used loggers, I am sure that you are aware of something like this. There are different flavors of loggers, but I am sure that you have noticed this logger, get logger. And if you think about this, get logger is a static method. Logger is a class, and we know that it's a class because the uppercase letter at the beginning. It's a class, it's a getter. Instead of get instance, get logger probably looks better, redundant. Logger, get logger. You are getting access to one and only one object, one and only one logger. And you can do this in all your classes in a project, and all your classes are using the same object, the same logger. And you want only one object, right? I mean, it doesn't matter what are you going to do with the information that you are recording, but all the information is going to go to the console. You have only one console. All the information is going to go to a file. It's going to be only one file. It's only one object, one logger. You use a library. That library, the people that implement the class logger follow the template singleton. You have this. Doesn't matter how many times you get the logger, in how many different places or classes, is a singleton. The desktop that you mentioned in the chat, not sure if you are aware of this, but in the Java API, since AWT, you have a class desktop. In the class desktop in Java, you have access to the desktop of your computers. And among other things, you can run a browser or some application from a Java application. You get access to the desktop, and then you have some methods that you can use. One example here is this browser, and literally it's going to open your browser in a particular URL, the one that you're sending as a parameter. So you can have this program in Java in which you click something or select something, and you open your browser in the desktop of your computer in a particular URL. And well, in order to have access to your desktop, what you do is desktop is a class, uppercase D, get desktop. Again, get instance. It's a singleton. Why? Because you only have one desktop in your computer. Your computer, whatever operating system you're running, is one and only one. There is an object that represents your desktop. You get access to that object, singleton, and then you can ask the desktop to do something. One and only one. Examples of singletons. In the libraries, in the frameworks, in the APIs outside, several different examples. It's easier to explain developers how to do something if those developers already have experience using a standard way. And this, or this, is a standard. One object, one connection. Yep. Not sure in which library, I do not remember, but probably I will say yes. If by any chance you have a console class in some place, probably it's a candidate to be a singleton. Again, every single time that you're creating something in which you know it's going to be one and only one, singleton is the pattern that you can use. And as you notice here, logger is a singleton, desktop is a singleton, console can be a singleton. The name of the class do not need to be singleton. And that is the main error that the people make. It's like, I am going to do a singleton, the name of the class is going to be singleton. No, if you want a logger, a console, a desktop, that is the name of your class. You are representing something. But that class is going to follow the template of the singleton. It's going to have a private constructor. It's going to have this getter with some name that is up to you to follow, get instance, or use something more according of what you are doing. It's a singleton. There is a recipe for singleton. Good? Yeah. As you notice in the chat, the philosophy, that is the core. Understanding the philosophy, the idea behind these patterns. Now, moving forward, this is singleton, kind of easy. Next one, decorator. Observer, a behavior, sharing information between two classes. Singleton, creation, one and only one object. Structure. Structure. What do we do if we have a person? Typical example. And I want to have a person, but you know what? This person is going to be a professor. Or you know what? I want to have a person, but this person is going to be a student, and so on. Typical example of I have person, but then I want person professor. The professor is a person, but with particular things that make them professors. I want a student. A student is a person. I represent that with this little guy, but a student have things that are more than just a person, but is not the same that a professor. I am sure that you're familiar with this kind of problem. And what is the classical solution for having professor, person, professor, student? What is the connection for them? How do we do the programming of these three classes? Is the classical example of inheritance, right? Answering the question in the chat, what happens if you call the singleton from two different classes or two different methods? Nothing. It's a method. You can call it from any place that you want. The singleton do not have any synchronization thing. So if these two different classes are threads, the problem that you're going to have trying to access simultaneously a particular resource is going to be the same problem that you could have without the pattern. So you need to be careful in the same way that you could be in any other scenario. If the singleton, the class that is encapsulating something, that something is going to be accessed by different threads, you need to synchronize. Again, just like in any other way of programming. The singleton, the only thing that it's doing is to guarantee that there is only one object, but do not take care of anything related with concurrent programming. So same problems that without the pattern, if that is the case. In our scenario, if you do not have threads, nothing happened. It's going to work sequentially. The first call that I receive is the first call that I respond. So the first call is the one that is going to create the object. The others are going to receive the copy, as usual in sequential. Going back here, inheritance. This is the classical example of inheritance. This is the classical example in which you'd say, okay, person is going to be one class, and then professor is going to inherit from person, and the student is going to inherit from person, and I am going to have this parent with two childs. A replacement of inheritance is the decorator pattern. When you have a problem like this one, when you have a class that is the parent, and somehow you notice that you can have childs, and the childs are basically the parent plus something. Two ideas. One, the parent and the child. Two, decorate. Think about it. A professor is a person with a decoration. A student is a person with a decoration. What is the decoration? The extra elements that you want professor or a student to have. Are you telling me that I can replace inheritance with a pattern? Yes. In which cases do we want to replace inheritance with something different? Well, depending on your problem, but two scenarios. Number one, when you apply inheritance, inheritance is going to add behavior or attributes, whatever, in compilation time. Compilation time, yeah, when you compile your program, you're going to compile the class professor, the class person, and the class student. In compilation time, you're creating those three categories. What happens when you use the decorator? When you use the decorator, in compilation time, what you are going to have is the class person, the decoration for a professor, and the decoration for a student. You're going to have three classes, yes, but they are not going to be the professor, the person, and the student. They are not going to be these three guys that I drew before. You're going to have three classes. The person, the extra thing that you need to, for some person to be a professor, and the extra thing that you need for some person to be a student. And I am using these draws used to exemplify things. That is what you're going to have at compilation time. What is going to happen at runtime? During the runtime, you can make the connections. In runtime, you can say, you know what? This guy here, this person, is going to be a professor. So I am going to decorate this guy with these elements that are the elements that the guy needs to be a professor. And in some point in the program, I can just say, you know what? Goodbye. This object is no longer a professor. Now, I want this object to be a student. Now that object, the same person with the same name, the same ID, whatever, the data. Now it's going to fulfill the role of a student because now I remove the decoration for professor and I am going to add the decoration for a student. So it's the same person with a different role, a different decoration. Moreover, what if I want this person to be a professor and a student at the same time? I can take the person and I can decorate that person as a professor, but also I can decorate the same person as a student, and I have this guy that have all the elements. Can I do that with inheritance? Can I have this guy, professor and a student at the same time if I choose to do inheritance? Yes or no? Your answer is depending the language that you are considering. If you're thinking in Java and we're working with Java, the answer is no, that is correct, because Java do not allow you to do multiple inheritance, right? If you think about C++, you can be thinking, well, I can define this class that inherits from professor and also inherit from a student, and this guy with those two parents is going to be the one in the picture, the child of these two. So the child have both elements, the decoration of the professor and the student. But in Java, you cannot do that. Moreover, if you review C++, one of the recommendations is be very careful with the multiple inheritance, right? The multiple inheritance is a very powerful thing that you can have. It's not exactly safe. Exactly. In particular, in the scenario that I am describing right now, we have the diamond problem, right? The diamond problem. I have person is the parent of a student and professor, and then if I create this child of professor and a student, I have this diamond. And what I have is this guy here inheriting twice from person. And even though you can figure out the solution, it is a very risky approach, the diamond problem. For those scenarios is that the decorator pattern can replace the need for inheritance, and in particular, in two scenarios. One, when you need more than one parent. Two, when you want to change the decoration, when you want to change the features in runtime. When you want to be able to have like a person and being able to configure dynamically person as a professor or person as a student. I am using this example just because it's the classical one in the books, but you can notice the power of this for several other scenarios in which you are using inheritance and in real time you want to update the extra things that a particular object could have. Looks like a good idea. Now, that is the problem. That is the solution. What is the pattern? Pattern. There is a class diagram and there are going to be source code. The class diagram, this is the class diagram, the template for decoration. What did you notice here? Two things. I have a family, and that family have two branches. The family have this, one of them is like the item, the core. This guy is like the person that I mentioned before. Is the item, the element that you want to decorate, the core. Person, your original object, shape, the data, raw data, whatever. The other branch of the family, the possible decorations. The decorations, whatever. Usually in the template, you are going to notice that for the original one, we show one class. However, you can have childs. There is no limit for that. We can have here different originals ones. For the decoration, usually the template is going to show you childs because it is more factible that the decorations are going to be diverse. For my example, this class is person, and for decoration, I could have here the one that I choose for professor. I am using draws, but again, the variables and the methods. And the decoration for student. Whatever is the decoration for professor, this is the class. Whatever is the decoration for a student, this is the class. And then we create families. Obviously, these two are childs of decoration. So when I read the class diagram, I know that this guy and this guy are decorators because the parent is a decorator. Moreover, these two guys, the item and the possible decorations inherit from a common parent, that is going to help me to use polymorphic behaviors. That is going to help me to handle one of the original items like a decoration or one of the decorations like the original item. Just create a family. Okay. In that point, this is trivial. The signature for the decorator pattern, this relationship there. Do we understand what is happening in that relationship? What is happening in that line that I mark? This one. That is the signature, the key element when we talk about the decorator pattern. What is happening there? What I am doing? I have a class, and that class is decorator, and that class is a child of component, but also that class has the diamond, a component. What is going to happen? Do you remember graphical user interfaces in Java? Do you remember in Java that you can create a panel? And you remember that inside of a panel, you can put a widget like a JBottom. Do you remember that you can have a JPanel, and inside of a JPanel, you can put another JPanel? And inside of that one, you can put another JPanel? And if you want, at the end, you can put the JBottom there. And you remember that you can do this as many times as you want. That one is the decorator pattern working. What you do when you create a graphical user interface in Java, combining panels with key elements, what you are doing is decorating. Really? Yeah. According with my diagram, if I create a new panel, a panel is like this guy here. It's a decoration. And as you can notice, this guy here is a child of this class here. And this class here has an object from this class. So something that you can do is in the panel X, you can add one of these. You should have a method that allows you to give a value to this variable. And what is the thing that you can add? A component. And that component can be another of this, another panel, like another panel, y equal new yes. The first one is this one, and this one have inside one of these, but one of these polymorphically can be this one, which polymorphically can be this one. So what I define with this connection here is this object X can have inside another object like himself, a panel that could have inside another panel. Can I continue? Can I do Y add another one like W? And W is also a J panel? And hopefully you can notice, yes, you can. And you can continue and continue and continue until you want to stop. But what if I want to have a J bottom B that is I do not want more panels. What I want is to finally add here the OK. You can do that also, right? I can replace this W here and put B, this B, and then you're going to have this one panel with another panel inside with the J bottom inside. This item here is the equivalent to that one, the widgets. Well, in fact, if you think about it, this class could be widgets, and then you have several childs here, and the childs are the label, the J bottom, the text field, and so on, all your widgets. The graphical user interface in Java is this class J component with two families, one family with widgets, the items, and the other family with panels. By the way, you have different kinds of panels. And these are basically the decorators for the original ones. Yeah, you get the idea. Similar thing happened with the IO package in Java. If you think about it, the class file in Java, you can create a new object file. And the only thing that you pass as a parameter to file is the path. Do you remember using this one as a parameter for other classes? And hopefully, yes. File as a parameter for inputs, outputs, streams, and so on. What you have is decoration, adding things to the original one. Use examples. So again, you are working with the pattern for different things, even though you do not know that it's a pattern. Now, the key idea here is that when you create something, a library mostly, or your software, well, you can take advantage of these kind of things also. Makes sense. Again, important thing, decorator, two families, they are connected. And this relationship here, one class that is going to be inheriting from another, but also is going to have an object from that class. That is the signature for knowing that you are working with a decorator. So doesn't matter the names, but when you have this idea of one class here, one child here, another child here, and it doesn't really matter if you have more childs down, it's irrelevant. But when you have this parent, the child, and one of the childs have a relationship that is a diamond beside the inheritance, this here is the signature we are doing decorator pattern. Now, source code. Hopefully, just looking at this, you can figure out the source code, but just to be sure, source code. Number one, let's start at the top. At the top of the family, we have one class, and that one class, hopefully you can agree with me, the only reason for the class component to exist is to connect the two branches of the family. That class do not need to do anything special. It's just going to be the connection. So that one can be an interface or an abstract class, whatever. In my example, abstract class, we are not going to create objects from that class. It's just the parent for the family. And there, you are going to define one method that every single member in the family, both items and decorators, are going to have. Help me. I showed you the example with the graphical user interfaces in Java. I showed you the example with JLabel, JBottom, JPanel. There is a method that both the widgets and the panel have in common. There is any method that you can find in both of them? Yes or no? According with this, they are using the decorator pattern. If they are using the decorator pattern, they should complete this, and the answer should be yes. If yes, which is that method? Well, add is the method to add the element, but it's not the operation. It's not this action that both of them do. Which action the panel and the widget both do? By the way, for the add, the panels, you can add things, but you cannot add something in the widget. We cannot add another widget inside of a label or inside of any of the widget family, right? So the add is going to be with the panel, but it's not going to be in the widget family. So add is not that method. Which is the method that is common to both the panels and the widget? What action both of them do? It's a graphical user interface. So what common thing happen with both of them? They are draw. I am going to talk about the listeners. The on-click is going to be connected with that later. It could be an option if we work with the listener for the mouse, but it is not mandatory because that is going to be something that we can add later. This one, remember, the method that you put in the parent class, this operation is a method that you're going to need to override in all the members of the family, right? When we put this common parent, the top, this guy here, all the classes that we create from this guy, all the classes in this family are going to have this operation in my example. For the Java, for the graphical user interfaces, every single element, a label, a bottom, a text field, all of them have a method and that method is the method that draw the widget. The panels also have the same method to draw the panel, the border, the background, whatever, paint component. That is the mandatory method that all the elements in the family have, because all of them are graphical user interface components. So all of them are going to be drawn on the screen. All of them have a method that draw them on the screen. In my example, for the template, I am going to use this operation, the general name, for the graphical user interface, paint component. What about the streams? What about the EO operations? There is any operation that is common to all the members in the family when we are talking about streams, data streams? Yep. Well, those, we need to review that, but those two really call one common operation. The operation, the action, the classes are going to configure reading or writing, sending or receiving, but every single class can do only one of them or both at the same time. It's going to be one operation. We can review the API, but yes, it's connected with that. Good. So the parent, the only thing to do is to define that method, whatever it is, should exist. How many? Could be one or more. How many? Whatever you need, depending on your problem. Which name? The name that is better for your problem, for your context. My example, use one operation. It's an abstract class, nobody needed. It's just the signature. So this one is very simple. Next. What about this one? That one? The item? The one that is going to be decorated? Important things. One, it should extend is this relationship here. Number two, override. Remember, in the parent, the method is empty. Responsibility of any of the childs of that guy is to override the method. Override the method, create the method. What is going to be the body of the method? Whatever you want. If you think about the paint of a label or the paint of a JBottom or the paint of a text area or the paint of a text field, each of them paints something particular, a border, the inside is white or the inside is gray, a shadow, a text, up to the problem, but override the method. That is the responsibility. Anything else? Nothing. The only thing that I have here in the diagram is to do inheritance. Override the method. Done. Okay. This guy here, that is the special guy. The special guy because inheritance and the diamond. Hopefully, guys, at this point, we agree that this line is the one and only one that is creating a diamond in your class diagrams. Attributes are diamonds. This diamond, this inheritance, those two lines. The variable? Professor, you have the variable protected. Yeah, I am going to create a family and I want the family to share the variable. Use here because I do not want to define a getter. I want to have my code as small as possible so it fits in a slide. You can put this one private. Yes, you can put this one private. You can define a getter and the child of this can call the getter if you need, up to your problem. As far as the variables are not public, you are fine. You are following the encapsulation principle. The extent and this one. You can use the name that you want. In the original pattern, the name of the method is setComponent. It's a setter. This guy is the one that in the graphical user interfaces in Java is called add. Is the method that allows you to add a value, to provide a value to your variable. Following the object-oriented programming things in the 90s, is a setter, and set and the name of the variable, setComponent. To make this easy to follow, Java, the API, the method is called add. You add an element. You add a panel to another panel. You add a widget to a panel. That one is your method add. This class, the decorator, the inheritance, the diamond, and the method add. And finally, the override of the operation. All the childs override the method from the common parent. Done. Did you notice the difference between the item, the widget, and the decorator? 1, 2. The variable and the add method. No variable, no add method. Simple. This part, this part. Okay. Now, what about these guys? The specific decorations. Nothing special. Inheritance, inheritance, and override operation. Always override operation. What you do inside, whatever you need. However, for the decorations, hopefully you notice the following. The rule is, it doesn't matter what do you add, but do this at the beginning. Help me. What is the meaning of super dot operation in this particular class? What I am doing there with the super dot operation? I am calling the method from the pattern, right? Answering the question in the chat, why is decorator abstract? The reason because I put here decorator abstract is because I do not want to create object decorator. I do not want to create objects from this class. Remember, basically that is the reason because you put an abstract to a class is you are using the class used to be the parent of the classes that are the childs. And I want the people to create objects from these classes. I want the people to create object childs, but I do not want to have objects that are used decorator because that doesn't have a meaning. This guy is use the parent. I put that with the abstract. In my previous example, with the graphical user interfaces, it used the parent for all the widgets, or it used the parent for this, the decoration for a professor or the decoration for a student. That is the point in which you add abstract or interface. Yes, you need objects from this class or from this class. You need the concrete ones. That is correct. This one is abstract. This one is abstract. You are not going to use this one. You are not going to use this one. You are going to use this, this, and this. In general, when you have a tree, when you have a family and that family is going to create a tree, what you are going to do is to create objects from the list, from the classes that are down. Usually the classes at the top or the middle are used parents that you are using to connect things. So that is the case here. This one is not abstract because I am using that one like the element that I want to decorate, but something that I can do totally valid is create childs here, and I can move this one to abstract also. So the two parents are abstract. I cannot create objects from the two parents. I want my user to create objects from the childs. So that will happen. Good. So going back to my question, why I am calling operation in the parent? I am basically calling operation here. Operation in decorator should be doing something important. Operation in decorator. Operation. Did you notice what is happening there? Are you telling me that if someone called the operation from one of the panels, one of the decorator items, someone is going to call operation from this guy, the outside. I call operation. This operation. And the first thing that is going to happen is that this guy, the one that I am asking to do the operation, is going to call the operation in the parent class. And the operation in the parent class is going to call the operation in the element that I have inside. So I am calling for the panel outside the window to be drawn. But that one is going to call the same operation, paint component in my example, for the element that have inside. But the element that have inside is also an object from the same class and is going to do exactly the same action. It's going to call operation for the parent, which is going to call operation for the object that I have inside. So this one is going to call operation for the one that I have inside. The one that I have inside, finally, is a widget. And widget is from the other branch of the family. The other branch of the family also have an operation, also have a paint. The only difference is that in the other branch of the family, here, I am not calling another operation because I do not have anything else inside. Did you notice the process? I call the paint of the outside. If that one is decorating something, it's going to call the paint, that is going to call the paint, that is going to call the paint. And the last thing to be drawn is the original item, the original widget. One call from me as a developer. If you have worked with graphical user interfaces in Java, you only call paint one time, and it's one time for the outside element. That set visible true for the outside, for your frame. Inside, you have everything that you need to every single element to be drawn. I have a question for you guys. According with this, in my example, I can only have a panel with one panel inside, with one panel inside, with at the end, one element inside. However, that is not true for Java. In the graphical user interfaces, you agree with me that you can have inside of a panel more than one panel. And inside of that one, more than one. And inside of that one, more than one. Moreover, you can have inside of a panel here, okay, another okay, cancel. So 1, 2, 3 widgets, and then a panel, right? It's not just a panel inside of the panel, is the panel and inside, yeah, another panel or widgets. And the same applies for everything. What do I need to do in my source code to allow this behavior? To be able to have more than one panel inside of one panel, if this is the case, or to be able to have either more than one panel or a combination of panel and widgets. Can you agree that the only thing that I need, the only thing, is to change this guy from one variable to something like a list wait, okay, you are going to have here a list of components that solve the problem of now you can have one thing and inside is not only one, you can have two or more. But it's going to work like this can be a panel, this can be a panel, and can I add a widget here? Or can I add 3 and 2 are panels and the other is use a widget? Or should I do more in my code? Just like that, I change the variable for a list and everything else is just going to work. And you get the idea that yes, it's going to work. This pattern allows you to add panels or widgets in any number, in any order, inside of another panel. And the same rule applies here. You can add 2 bottoms, and if you put a panel here, you can continue adding widgets inside, and you can create whatever crazy combination that you want. And what you have is the solution for how the graphical user interfaces work in Java. And the only thing that you needed is 1, 2, 3, 4 slides with code that is less than 100 lines. And hopefully with this, I share with you how simple it is to create what could be a complex graphical user interface. But the same idea works with any other kind of data. Questions? Fine. Good. Now, in the main, how we put together things. I am pretty sure that you're familiar with this. I create an object. I create decorators. If you want to think about it, the object, the decorator, and if you want to have decorator A and B, remember that you can have panel, panel with the scrolls, panel with tabs, and so on, different kind of panels, different kind of decorations. And at the end, you connect them. And you connect them, and I am sure that probably if I show you the add, panel 1 dot add the widget, and the panel 2 add the other panel, and I have 1, 2, and something inside decoration. And then the operation to the outsider, everything is going to be drawn. Done. That is the pattern. Okay, so if I run the program, obviously the key idea is that the operations are run in the 3 elements, not only in 1. So far, so good. Question in your exam. What about if I need these classes? You know what? I need some kind of guy, class, that is going to be a companion. And then this guy have these childs, a companion that provides help, and a companion that just make fun of me. You can think about a bot in a chat, and what I am going to do with these classes is a chat bot, and both are chat bots, but one is going to help me with something. Maybe I put a question and it's going to reply with an answer that makes sense. And the other is just going to troll me. Two of them. I would like to have also this possibility of one of these guys that could be both randomly. Sometimes help me, sometimes troll me. If I ask you to do a chatbot and I ask you to provide that guy with these two different options of behaviors, and in some point it's open the possibility that I can combine behaviors, immediately you have with inheritance the diamond problem, as I described before. Solution, move to the decorator pattern. If I move to the decorator pattern, can you imagine the class diagram for this? Moreover, the classes for this, the programming for this. And I know your problem is, what do I do to create a chatbot? But those are the methods and things that are going to happen in this particular class. That is a problem that you're going to solve one time. But thinking about the decorations is exactly the structure that I described before. And operation is the only thing that is going to change. Something is going to happen with this method operation. Operations are going to be different. For help or for trolling is one method, the one that is going to change. And all the classes are going to provide that method. Source code for something like this without multiple inheritance. Source code for something like this used in Java. Can you agree with this class diagram? That is basically a copy-paste of the template for the pattern. What is happening here? Because the class diagram is slightly different than the template for the pattern. Can I do these small changes? In particular, I would like to ask if you notice what is happening there and there. Do we notice that now the line is not solid? Why? What are you doing, Professor? Why this line is not solid? There is an error? Can you agree that what I am doing in my solution is, you know what? This companion guy is going to be an interface. Can I transform a companion to an interface instead of an abstract class? It's the same context. I am not going to create an object from that one. Moreover, I am not going to put variables there. I just have the signature for a method. I can make an interface. It's going to be an interface, and therefore my diagram changed a little bit now with the not solid lines. In my example, this guy, the guy that is alone, that one is this one, the solitary one, the original one, the empty one. One branch of the family for him, for the element alone. Another branch of the family for the decorations. The decorations. This is the class. This is the decoration. This is the decoration. The decoration is just the elements that I am going to add, and hopefully that part is clear. I copy-paste the same draws, but I want to make clear. The class that represents the decoration, in this case, could be a class that just represents the mask, whatever that is. Or in this case, the class that represents the helmet and whatever extra thing this guy has. I am going to add the mask to this guy, or I am going to add the helmet to this guy, or I am going to add both, like this. Runtime, I am going to decorate the guy. That is the reason of the name. So add. do something, do something, do something, do something, do something. And if this one have the add, inheritance. No variables here, but there is a diamond. Can you create the source code for this diagram? And hopefully, like, yeah, it's the same as the previous one. Whatever extra thing you want, but main. I am playing with the different combinations. Companion with the do something. The basic guy, empty. The decorators. The class that is the parent of all the decorators. The helper decorator. And the other one. Homework. Can you review this source code? This one, this one, this one, this one, this one, this one, and make sure that if you run this one, you are clear why that is the output, and how is that I have one that is kind of basic, another one that is kind of helping, and another one that is doing two things. No decorations, one decoration, two decorations. Just be sure to understand how this works. Any question, guys? Perfect. Please review the source code for your exam. I mentioned that you are going to have open questions. Your open questions are going to be programming. That is what I am going to ask you to write. And as you can imagine, the programming is going to be related with patterns. Several questions. When you are doing programming, what I am going to ask you to do is tell me what is the source code related with a particular class diagram. And as you can imagine, that particular class diagram is going to have diamonds, arrows, composition, association, realization, but also now patterns. I need you to remember which source code is associated with each pattern. It's not a lot, but it's very key elements. My recommendation, play with the source code, familiarize yourselves with how this works and what source code is equivalent or connected with a particular diagram, the diagrams that are related with the patterns. Any question? We continue next lecture. Thank you.